Hey everybody, welcome to the 8th session. We're like, this is like the halfway point of the course. It's kind of crazy that everything has gone by so quickly. Um, yeah. So, uh, so sorry. And I had like bonus office hours, and so then I didn't like have the time to sort of like get my head into class. So I think it's gonna be a little of a rough start tonight. I apologize in advance. But this is going to be an interesting class tonight because I've got a little bit of content that I want to present. I want to talk about continuous integration and what that means. I'm going to explain some things that you've been seeing from GitHub. But then the bulk of our time together tonight will be our second pair programming activity. We have the opportunity to, some people have joined us in the classroom, so thank you for doing that. It's great to see everybody who's here. And some people chose to work remotely, which is fine. Remote pair programming is completely valid and something that more and more people are doing, although I've found it's a very different experience. So I'm really curious to hear what you all make of remote pairing. But to start out with tonight, let's do Prime Minister's questions. So we had a handful of things that were due tonight: quiz, midterm survey, but most importantly, Project One. And so, been lots of good questions throughout the week, and today that I've been fielding. But what questions still remain about Project One, or what can I tell you about Project Two? Actually, we'll start with Project One. Anything else about Project One, either in terms of questions or feedback or observations that you'd like to share with me? I think I saw a couple of questions come in. Will late submissions count for Project One towards our freebies? Yes. So as a reminder, the policy is that each student has 2 late days to use during the term, which means that you can, if you submit project, one like at midnight tonight, that'll be one of your late days, and then you can use the other late day for Project One, which I hope you don't burn, or you can use it for a later project. But yes, Project One, you can use one of your late days for that. Let's see here. Oh, question: if we write description unit test names, will we write a comment explaining the test? No, you don't. And I think this came up. This question, a similar question about Javadoc for unit tests, came up in Slack. But no, it's not necessary, and actually there's no need to write API documentation for unit tests. So when you run the Maven-P grader Javadoc: that will spit out that will generate text for the API documentation for your source code, the stuff in source main Java, and that's ultimately what you'll be evaluated on. So there's you don't need to write you don't need to write Javadoc for your unit and integration tests. Let's see here. What is interesting about the Maven site info.index file that is kind of useful to view for us right now? Oh yeah. Some people might have heard me talking about this earlier. Let me show you. So I will go to my checkout here, and I will go to my phone bill. And okay, so it's all about code coverage. So I might have covered this earlier, and I apologize if I didn't. There are also some details about this in the how to test your projects handout. But if you run Maven W, and well, let's see, I'll run Maven W-p grader verify. And this is for my phone bill, and I don't expect this to pass because I don't have complete code coverage. So hopefully all of the unit tests will pass and the integration tests will pass, but the build ultimately will fail because I don't have the required code coverage. Let's get to that. Yes, and that's what I did. So build failure here, and looking at this output, you see things like code coverage checks have not been met. See log for details, and sure enough, if you look up above, there's a warning saying rule violated for bundle phone bill. Instructions covered ratio is 0.67. but the expected minimum is 0.75. So as hopefully you recall from the How to Test Your Projects handout, the requirement for code coverage is 75%, so 0.075. So this begs the question, well, I've written some automated tests. What code still needs to be tested? So if you run Maven Site, and we'll talk more about Site, well, we might get to it as part of the continuous integration. One of the things that Maven does, and one of the things that you'll learn about in the Maven lecture, if you haven't watched that already, is that Maven can generate, well, a website for your project. It's one of the cool things that Maven can do, and what you end up with is a site that then, documentation for your project, including like its, Java docs, and you can run all sorts of analyses on it. How complex is your code? Do you have bugs in it? All sorts of great stuff like that. But the other thing they can do is it can generate a report for code coverage. As you may recall, it uses our projects use a tool called Jacoco for Java code coverage to assess all of that. And now if you open up the target site index.html file in your browser, you get this report, you get this website for your code, for your project. And if you go to the project reports section, Jacoco, now you have your code coverage. And so what you see here is a nice visual report that gives you an idea of, well, where your code is and is not covered. And so what we looked at is missed instructions. And so it says, oh, great, 67%, which matches what my Maven told me, 67% of my code is covered. And so I can drill into, first of all, the package. Now I can see the classes in that package to see how much they're covered. So like my phone call has 50% coverage, and you can then do it by method. Or you can drill in and see the whole class itself. So here, my phone call, what it was telling me is that the phone call class is green because there's some coverage on the class. But like, for instance, my getCaller method here in red indicates a method, or sorry, a line of code that isn't covered. And so then, so I should write a test, a unit test that then calls the getCaller method so that this line of code will be covered by a test. And so this report then gives you an indication of how well covered your code is. I can look at the main method, for instance. It's a tiny little main method, but it's like, oh, look, yep, this code is called, but I never reached this line right here, right? And so, this is something that you can drive from red to green. So does that answer the question about the Maven site? I hope it does. Again, those commands were Maven W space site, and that will build the site. Can I post those in Slack? Absolutely. And let's make a little note here.
Is it intended that the auto-generated text parser file that's for project 2 has enhanced code coverage?
The auto-generated what file now?
So when you run create project 1, it auto-generates a text parser and text dumper files, which are for project 2. But the methods in there are being counted against the code coverage.
Yes, but I think the code coverage should still be pretty good without it. I mean, like 80% and 100% of my stuff out of the box, and I haven't made any changes there. So it's true that yep, there'll be one line of code here that most likely won't be covered, but everything else should. If you find that you've got more than 75% covered of the code for project 1, and like what's preventing you from getting 75% coverage is something in the text parser, reach out to me and we can talk. That probably won't be the case though. So again, it's one line here, maybe two because there's not an IO exception thrown. But yeah, so I think yes, they are in scope of the coverage, but I think by focusing on having test coverage for the classes for project 1, you should be able to reach 75% by focusing on that pretty easily. Let me post that stuff in Slack. Use Maven W site to generate HTML reports for things like code coverage. view the Coco reports to dig into coverage, and I will put in a screenshot of, oh, and sorry, I should probably say open up. Open the target index.html file to view the reports, navigate to the Coco reports to get the code coverage. Let's go back to index.html, click on project reports, and then Coco. Oops. Screenshot there. Let's see here. Oh, and thanks for posting the link to the how to test your more information at testing. Yep. Let's see here. Question: will we get docked points if Maven W site fails? No. As part of grading, I don't build the site. What I run is the grading script. Grading script runs 2 Maven commands to, well, of interest. So what it runs is Maven W -p grader javadoc :javadoc, and again, this was described in the how to document your code. Handout command to generate a text version of your javadoc API, javadoc comments, and then Maven W -p grader verify command to run code coverage and coverage analysis. If the build will fail, if code coverage is less than 0.75, 75%. Let's see here. Yeah, so if one of the Java docs is incorrect, well, I mean, if you just have like a typo or something like that, the grader's probably not going to notice. But really what we're looking for is just quantity. And, as long as it's not like Lipso or Orpsum or, made up words or something like that, it'll probably be okay. So yeah, those are the two, commands that the script will run. And those are, those are the two commands that I use. Nice. Yep. So I know that we went through. It was probably on July 3rd, right, where I went through those two handouts, and I know it was probably towards the end of class, and it was pretty fast and everything like that. But yes, those are the commands. You'll see these when you get the grade reports. They'll be there in terms of the output that's been executed. But that's what you need to do, or rather, that's what the scripts do. They run the javadoc command to get the javadoc comments, and then run verifier with a p grader, which is the grader profile in Maven, which enables some additional things like having the build fail if code coverage isn't complete or isn't 75%. Yes. Okay. And the javadoc is printed to standard out. Thank you. I'll say I'll modify my comment here. I will say generates instead of just generate to print out a text version of your javadoc as a standard output. Nice. Okay. How did you find project one? What was challenging? What was easy? Anything surprising? Anything you'd like me to know in terms of your experience?
Getting my head around the idea of where the ID begins and begins for trying to do some of this stuff. Because I got really used to it with the ID. It starts doing all this other stuff. So okay, I got to start using all these commands instead.
Yeah, that's, yes. Yep. Yeah. Yes. Yeah, that's a good point. Yeah, I mean, the way, while we do a lot of the stuff, almost everything in the IDE, ultimately, yeah, when you submit the code and when I grade the code is done with Maven. And so then, yeah, I guess getting an appreciation for the Maven commands as well as the work in the IDE. Yeah, it's sort of some fundamental stuff that I'm glad that you get to experience that in Project One. See, here's some other comments came in. Writing unit tests isn't fun. Thinking of all the cases is difficult. Yeah, it is challenging. And so I guess it might be a little solace or cold comfort, but I think you'd rather think of the test cases yourself and implement unit tests that pass than relying on me to think of the test cases for you. So I think that's also part of it, where the code coverage and doing test-driven development is meant to make you think about, okay, well, what are the things that I need to account for in my tests? It's all part of the exercise. But yep, it's difficult, and it might be something different than what you're used to. Overall, enjoyed it. Looked like found it still covered a lot of familiar topics. Okay, good. I hope there were some things, or I hope most things in terms of the actual coding that was familiar to you. Things like loops and working with strings and stuff like that ought to be pretty familiar. I think you'll find Project 2 is when you start to get some more experience with the Java APIs and do some different things. Yes. Okay. Speaking of Project 2, I know that you're probably still finishing up, or you just finished Project 1. Don't know if you've had any time to really start exploring Project 2, but any questions about it since we're talking? I believe it is due a week from tonight, so no rest for the wicked. Let's make sure. Yep, on the 24th. So then, I encourage you to start it as soon as possible. Yes, the plan of attack is due on Sunday, so you can't wait until Tuesday night to start it. But be sure to read up on the I guess the I/O. Yeah. The I/O lecture to give you the background on things like writers and print writers and all that kind of stuff and file writers and file readers to be able to implement the parser and the dumper. A little bit more Project 1 commentary. It was all right. Test-driven development for me is an acquired discipline. Yeah, still trying to figure it out. But yeah, that's okay, right? This is sort of like, hey, we're only halfway through the course. And you'll have lots more opportunities to work with writing unit tests and integration tests in the rest of the projects. Nice. Anything else for Prime Minister's questions? Anything else on your mind? Okay. Yeah. We'll be getting to the Kata in a little while. I want to talk about continuous integration first. But yeah, if anyone wants to start planning ahead, getting your environment set up, pull down the latest changes. There will be new projects for tonight. It's called Diamond. Is that what tonight is? Sorry, I'm a little lost here. Yeah, tonight is Diamond. Okay. Yep, and it's in the Kata Summer 2024 repository. Yeah. So then, let me get my IntelliJ up here. Yep. So yeah, you should have a checkout of the Kata's repository, and now it contains, let's see here, let me go to the main branch. My checkout, main, checkout. And then let's see if I need to update anything. Out. I can, yeah. It's in the Joy of Coding. Actually, I've got it. Yeah, I'm sure I've got it here in some sort of tab. Yep, right here. I'll do it to what's that? Okay, so many things going on at the same time. Kata's tonight. We're doing Diamond Kata. Yes. Oh, what heck, why not? Let's just jump ahead here a little bit. Anybody who wants to read ahead about what Diamond Kata is talking about. Okay. Yeah, first I want to talk about continuous integration. Oops, that's testing. That's app classes. That's that. Where's my? I just haven't opened up that. Okay. So on Monday we talked about. Oh, thanks, Amber. We talked about code refactoring, right? And we did that Gilded Rose kata where we saw some code that was really ugly and blah, blah, blah. And the whole reason that you refactor your code is so that it's easier to work with and you can go faster. You know, because machines are so much faster, the computers are so much faster than humans. Really what we need to optimize for in software development is the ability of us humans to get ideas from our brains into the computer as fast as possible. And so things that stand in the way of that, like hard to read code, like environments that are slow to work with, or code bases that require a lot of that are complex and require a lot of cognitive load to be able to reason about and work with. Those are things that slow us down, and those are things that we should try to improve, like things like code refactoring. But there's another technique in contemporary software development that also provides rapid feedback that will help us find mistakes that we make sooner and give us confidence that we're doing the right thing. And that's called continuous integration. So, as we've said we've explored a couple times in here, as you develop software that people like and that will live for a long time, you want to be able to do so confidently and quickly. And so then, and as you work with others to develop software, you need to share your code. And so we've seen how you can use Git and GitHub to share your code with others. This is great, so we're all sharing code, but when it comes to giving that code to somebody else or something else, so like you're done with it, and it's great that it works on your system, and maybe you and your fellow developers have all got it working and stuff, then it needs to go to somebody else. Now, I mean, back in the old days, you would put it onto a CD or floppy disks and put it in the mail or put it in the in the store, and unless you're writing tax software or whatever, you don't really see that very much these days. But instead, you would deploy it to some production system or to a test system along the way to production. And so what you need is like the official artifact, the official build of the source code that then goes on to have other people consume it. And so it begs the question, how does that sort of official build of the source code get made? Now, for many years, a lot of source code was literally built on some developer's machine, and then they copied the bits over to a production system. And as you can imagine, that was error-prone. And sometimes you had software that was hard to reproduce because you didn't really know its pedigree, and there might have been something special about the machine that it was built on. And so then, over the years, these systems for doing what is called continuous integration were created. So it really, continuous integration evolved from a couple of things. First of all was source code management tools like GitHub. But then also build systems like Maven helped move the needle, right? So in Maven, and I hope you had a chance to watch the lecture, Maven is all about a system, a software that builds software, right? And as you've experienced, the Maven defines the Maven project, defines how the project's code is built, how the unit tests are run, how an artifact like a jar file is built, and how integration tests are run. With all of that, what you end up with is a build system or a build process for your source code that not only compiles it, but also validates the quality of it. And you all run that on your machines, right? You probably ran it locally on your development box, and then you push your code up to GitHub, pulled it down on the PSU machine, and did the same thing, right? You ran the Maven build to make sure that everything behaved as expected, and then you submitted it. Continuous integration adds another component to that, which is something called a continuous integration server, or traditionally it's been called a continuous integration server. And so the idea here is that you have a separate standalone server whose responsibility is to monitor the source code management system, something like Git or GitHub. And whenever a new change is committed, pull down those changes and run the build process on that machine. So, for instance, for your projects, it would entail pulling down the source code, running like a Maven command like Maven verify to basically run the end-to-end build of the project, everything from compiling code to running unit tests, and then validating that in essentially a clean room environment where you've got all of the where you've gone through the entire build process in such a way that you're not worried about the changes that might be particular to like an individual's machine, something like that. And what this does is, and then if there's a problem during any of that, if the code doesn't compile or there's a test that fails, the continuous integration server sends feedback to the person or persons who made the change. And so this is really great because what it gives you is, even if it works on your machine, if it doesn't work on the build machine, then there's probably a problem someplace. And you as a developer are informed of it in a reasonably timely fashion, hopefully within minutes of you committing the change that caused something to fail. So this helps you find errors in the build, and it sort of does so in an agnostic way because it's not a human telling you that something is wrong; it's a machine telling you that something's wrong. And so then, more likely, you can say yes, it's the machine's fault, but more likely it's your fault. So this gives you rapid feedback and helps you find errors in your code. And you can also use this continuous integration, either server or a set of servers, to have what are called quality gates in your build pipeline. So, if you think about the journey that your code takes, a change to your code takes to get from, your fingers, or actually it goes from your brain to your fingers into the machine. It then, once you're done with it, it goes on this whole journey to get to ultimately the user, the person that uses your software. So you can imagine if you are building, a web service or a website that has, or an app with which someone interacts. There's this whole series of events that happen, right? You commit your code, and then the continuous integration process kicks in. There will be a server that notices that change. It'll go get that change, integrates it into the rest of the code. That's why the continuous integration. It's the integration and continuous integration. It will run your build. It will create the artifacts. It'll run all the tests, and it might publish it off to maybe a staging server where additional tests will run on it. And then finally, if all those tests pass, it might be promoted to production so that someone can use the changes right away. And what this does, it provides all this validation, and it happens all automatically without a human having to be involved. And so this ends up saving a tremendous amount of time and allows things to go very quickly. Great question about GitHub Actions. I'll be getting to that shortly. But the answer is yes, GitHub Actions enable continuous integration. So by automating all of this, it removes a lot of toil. Back when I started my career, there was there was like a person whose job it was to like perform the builds every night. And so they would, they say, okay, yep, 5 p.m., okay, all the developers go home, and now I start my job, which is you have to get the latest source code and then run all the compilation scripts, make sure all that happens correctly. Okay, maybe fix a couple of things if something went wrong. Okay, then to assemble everything, and then to say, okay, this is the code, this is the version of the application that should be tested the next day. And because the human was doing it, not only was it toilsome, it was error-prone sometimes, and only one, and it was a piece of siloed knowledge, right? All the developers knew is, I'm working on my system, and I checked it in, and now it's someone else's problem. It wasn't deluxe. But once this stuff thing was automated, the developers became more involved and aware of how the code was tested. And they started working in smaller batches because they would get feedback much quicker. They wouldn't have to wait until the next day to find out if they broke something. With the continuous integration server, they can find out within, again, a matter of minutes, sometimes seconds even, that they had, that they made a change and either, yep, it's still okay, or there was a problem there. And so as a result, you could develop faster. Things could get out there sooner because you get more rapid feedback. So again, what continuous integration does is it looks for changes in the source code repository, and when it detects a change, that change has been pushed up to Git, for instance, GitHub, it will provision a new environment and build the code in that environment. It will have all the tools it needs, the Java compiler, and if it needs to set up an Apache or something like that, right? It's got all that stuff there. Then it builds the application and runs the automated tests. Very often there are code analyses that are performed. These days, most, actually probably any organization that does work with the federal government has to scan the third-party libraries they use to make sure that there aren't known vulnerabilities in them. So again, looking at your code, making sure that your product is good, again, those quality gates. Maybe it will generate some documentation and some reports based on all these analyses, and packages everything up and then sends it someplace else. Very often, if it's like an intermediate artifact, if you're building something like a library that contributes to a larger application, the library will be built and published to an artifact repository. And then other components can consume that library. So there are a lot of CI servers out there, and there's been a lot of evolution. But you've been using CI, and maybe you've realized it, and maybe you've not. So as was mentioned in chat, GitHub has a relatively new, it's been around for a couple of years, capability called GitHub Actions. And what GitHub Actions are is, a continuous integration process that is configured for your GitHub repository. So in all of our repositories that we deal with, there is a .github directory that contains a workflows directory, and inside that there is a YAML file called maven.yml. And what this does is this is a file that GitHub will look at to perform a continuous integration build. Okay. I'm not going to go into this syntax here. As a matter of fact, there is a link on the home page. If you want to know more about that, you can go off and learn all about building Java and Maven projects with GitHub here. But I'll just say, generally speaking, you configure to do things like saying, hey, listen, perform a continuous integration build whenever there is code pushed to the main branch or any branch that ends in -snapshot. Same thing with pull requests. If someone makes a pull request for a particular branch against a particular branch, run a continuous integration build. Again, this is someone saying, hey, I want to make some changes. Are these changes good? And then what you can also configure is you can tell GitHub, hey, when you run a continuous integration build for this repository, here's how to do it. So you provision a machine that runs the latest version of Ubuntu. And for me, I do 2 runs of the continuous integration build. one with Java version 17 and the other one with Java version 22. And then I go through some steps to do that. First, I make a checkout of the source code. Then I configure the JDK that I want to use. I do that with a set of Java command. And I can say things like I want to use, the Tamarin distribution of it. And if you go read about it, GitHub Actions support gazillions of tools, and especially the more popular ones that like Python builds and JavaScript and Node.js, all that kind of stuff. It's really great. And finally, I tell it what command I want to use for the build. And so in this case, I want to do a Maven verify with the pom.xml. That's in the top level directory. And so and then I just check this file in to my Maven repository. And because it's in a well-known location, GitHub will do the following. Oh, question. What is snapshot? This is the name of a branch. So it's a wildcard expression that will match the name of a branch. You all don't use it. I use it like when I put up new releases of things like the grader.jar and everything like that. But I don't know. I carry it over here. I suppose I could take it out of the getting started repository if it's confusing. But actually, no, I don't want to take it out of the getting started repository because I use it on getting started. So the whole idea here is like when I create a new let me get back to that because there's a tangent that I want to go on, but I want to finish talking about continuous integration first. So you can configure GitHub Actions to do continuous integration with a YAML file like that. And when you do this, you then go to GitHub, and like I have it here for my Kata's repository. You'll see there's now an Actions tab here. And if you go to the Actions, you'll see here's the run of, so you'll see that there are all these different runs here. And this represents, well, every time someone pushes to this repository, the continuous integration build happens. So everything these are a whole bunch of changes that I've made to the repository. And it goes off, and so like this is when I added all of the Kata projects for the Diamond project, which is the Kata that we'll be doing tonight. And it gives me, and it said, okay, great, you did 2 builds here, one with JDK 17, the other one with JDK 22. And I can dive into this, and it gives me this big old log that corresponds to everything that I did in the YAML file. Oops, in the YAML file. So all these steps here, like checking out the source code and setting up Java, and then building the Maven project, all end up with these steps here. And so you can look at things like, okay, here is the here's what happened when the continuous integration build checked out the code, right? They go and well, I mean, there's also stuff you can dig into here, like initializing the repository. So okay, it does a git init, and then it does an add remote origin, and then it does a log and probably fetches and things like that. But probably the most interesting and relevant thing is the building the Maven project. And so what this does is it runs the command that we told it to in the YAML file. It runs maven w with a verify and that pom.xml. And it goes off and runs it. So this is just running Maven. And so it downloads, it's just like you're running Maven for the very first time. It downloads a gazillion third-party dependencies. Actually, I'll just go down to the bottom here. But it does all the Maven things, like it runs your tests and all that. And if there's any problems during this, the build will fail and you'll get an email. As a matter of fact, I think some of you asked me, it's like, hey, I got this email from GitHub saying that something failed. What happened here? Well, what was happening is that behind the scenes, every time that your pair committed something up to push something up to GitHub, it then ran one of these continuous integration builds. And then when it failed, it told you about it. So for instance, we could probably go back in time to like last week. But those are a bunch of, or maybe not. Do I only see mine? Let's go back to last week. I'm sure there were some, okay. Yeah, for instance, right here. So, yeah, right. So there were some times that, that it was failing because, yep, there was some code that didn't compile. Actually, we can probably just go and find it. So like with this one, there were some jobs that failed. Oh, and it brings me right to the failure. So, okay, great. While I was running the Maven project, here was the problem. Okay. So like, yep, there was something that, yeah, there was some code that didn't compile. Okay. And again, and probably somebody got an email about this. This is really cool in my opinion because it lets you know about problems when they occur. So even if you didn't catch it in your development environment, and because we're pairing and we go to the end of the time box and everything like that, yep, doesn't surprise me that there's code that doesn't compile. But you get feedback on it. And that's the whole idea behind continuous integration, is that it provides you with feedback quickly. And the nice thing about GitHub is that it's very well integrated into the whole GitHub experience. So for instance, here I can look at a commit. And if I see a commit that has a green check mark next to it, that means that the continuous integration test was successful. Well, the continuous integration build was successful for that particular commit. Again, and in conclusion, the whole idea is that you now get feedback on your build automatically every time that you go and share your code out. And this is one of those things that's really important as more and more people contribute to the code base, and as more and more tests are written. You want to make sure that your build stays clean. So many places, or in many development environments, in many shops that develop software, when the build fails, kind of an all hands on deck to get it fixed again. It's kind of like in auto manufacturing when there's like a part that's that's defective or something, and they pull the chain and the whole assembly line stops. The manager's like, okay, what can we do to go help? Get these things fixed. This is a very important signal of quality when you have code that enters your change that enters your code pipeline that causes problems. You want to get those problems resolved as soon as possible. So you need to know about those problems as soon as possible. And let's see here. I think that's it. So lots more to learn and to experience with continuous integration. But it's an important part of contemporary software development. Is again getting this feedback, and it kind of comes for free with GitHub. And so it's something that I wanted to explain a little bit about. So let's see here. Any questions? Does a merge count as a push? Like if someone did a pull request and merged into that branch, that would trigger the action? Yes, yeah, it does. Yeah, Ethel answered that question. That yes, it does. So the whole idea is that I'm either about to make a change or I made a change. Go make sure that new code is still that the build of the product behaves as expected with those changes. Is this concept familiar to you? Have you encountered continuous integration before? A couple of people have. Okay. It's funny. Maybe today this seems sort of like, well, hasn't it always been that way? I feel a little old, but it's like, no, it hasn't. And again, for me, continuous integration is just one of those things that really moved the needle on software development because it gave us feedback that is that's good. Oh yeah, great. People are saying you've used it like in your internships or at work or whatever. Yeah. Travis was great, and was it? Shoot, yeah, I remember like the first time I saw this, I'm like, wow, this is really great because it's like you don't need to pay someone to do it. Yeah, or Jenkins is another one, and now all the stuff's in the cloud, and it's just actually it's just like version control is like, yep, everybody's just so used to it. It's hard to imagine a time without it. But things are so much better now that we have these tools. Nice.
Yeah, we can't have any local job that everything's got to be open JDK.
Oh.
Into all of your Jenkins nodes.
Oh, yeah. Yes. Okay. Yeah, actually, so yes. You bring up a good point. So now these build pipelines aren't without cost, and it is more infrastructure that you need to maintain in your organization. And so then maybe there's an argument to be made that the people that 20 years ago would have been building, what was that person that started working at 5 p.m. to integrate the code? That person still exists at companies, but what they're doing is taking care of the build pipeline instead, making sure that all of the build machines are up and healthy and don't get out of whack, don't run out of disk space, right? So yeah, there's other things for them to take care of. Well, right, yeah. Yeah, you got to feed your cows before you turn them into steak. And so then, however, the way I look at it is that there is this amplifying effect for automating all of this. And while, yep, sometimes it's a chore to keep everything healthy, what you end up with is much more efficient and effective software development because you get feedback so much faster. Oh, automate yourself out of a job? Automate yourself into a better job, right? That's what we all do, right? Again, I'm talking like somebody's dad, because I am. But like, if I look back at my career, and like, I've been in the field for like 25 years now. And it's like, when I think about when I started and where I am now, I know a lot more, but I'm a lot faster than I used to be. Because yes, I've learned a lot of things, but I've also automated a lot of things. And what I've learned is that when you need to scale, which y'all need to do as we go forward, automating helps. And so for me, the most relevant example for the course is like how I've automated things like the submitting process, and then being able to just like fetch all the assignments and run them through the script. Right, that saves me a lot of time. That lets me serve more students and drink more beer. Right, we both win. And so then, whether it's building your software or getting feedback on it or analyzing the code, we have these tools for a reason. And what a tool is supposed to do is help you go faster by reducing the cognitive load or just the time on task that you have to do something. So that's what a good tool does, that's what good software does, and as software developers, that's what we should be aiming to do. Make somebody's life easier. Solve a problem that they have in a way that is so compelling that they'll use our software, maybe even pay us for it. Nice. Great. Any other topics or questions about continuous integration? Anything else on your mind about what we just covered? Okay. Someone asked about the snapshot here. Now, okay, this one comes part of your grade, but I do want to go on a little bit of a tangent. I think I covered this. I covered this in the GitHub lecture, if you can remember that one. So, software is versioned, right? So, like when your projects are version 1.0.0, right? Oops. 1.0.0. Let's be consistent. 1.0.0. And this is all specified in like the pom.xml, right? So artifacts have a version. So here is like the top level pom. They all have a version 1.0.0. There are other artifacts though, like the parent pom here, which is version 1.1.1. This is all built from source code. And so the technique that I use when I want to change the version of something is I create a branch in the repository to develop that new version of the code on. Right? We'll call it a feature branch or a version. And I talked about this a little bit in the GitHub lecture. But the thing that I want to talk about is what what the version number means and how you know when you want to increment or change the number of version. Actually, I guess this was part of the GitHub lecture, and so I just want to, I don't know, it seems relevant because we're talking about building software tonight, to reiterate some of that stuff. So let me find the GitHub or the Git lecture real quick, and actually I'm going to go to the full screen version, and it's semantic versioning. Okay, make it a little smaller. So. When it comes to the software that you make, especially the constituent libraries that go into an application, or components that you build and deploy into production, the services that all build, that work together to make an application. It's really important to know what version of the software that you're using, because that tells you, what features it has, and when you have to diagnose problems, you want to make sure you have an accurate inventory of all the pieces, parts that go into like the particular build that you're using. For a long time, software versioning, the sort of like the specifics of it were kind of ad hoc. You see some software that would have sort of a 1.1 version, and then it would go to version 5 for some reason. And then you realize it was all marketing. It's like, well, that doesn't help me very much as someone who's technical and trying to understand these things. So several years ago, this notion of semantic versioning was put forth, and it caught on pretty well. So the whole idea is that you've got you've got a version of a software component that has three parts to it: the major version, the minor version, and the patch version. And you've probably seen that some might have a fourth version in there or whatever, but we'll just go with major. What is defined in semantic version is 3. So moving right to left, the patch, you increment the patch patch part of the version when you've just made a bug fix that doesn't actually change anything outwardly facing, or more likely you're correcting something to be the way it's supposed to be. So like, hey, maybe your code has some API that you're programming to. If you make an internal change that doesn't affect the API, then we'll leave it as that. And again, doesn't impact external behavior, or at least the shape of the external behavior. If you make a change to your API that is backwards compatible, so you add a new method, or mainly adding new stuff is it. Then that's when you would increment the minor version. This is a signal to other developers. It's like, oh, there's some new stuff here. And so that when they integrate that new version, when they take in that new version, they know to look for new things. Or that maybe to be like a little bit more aware. It's like, oh, there's more stuff going on here. And so then this is, mainly semantic versioning is about talking about the API that your component provides. Now note that when you increment the minor version, you'll reset the patch version back to 0. So you'll go from 1.0 to 1 to 1.1.0. When you make an API change or increment, or introduce some like big new thing to your software, that's when you increment the major version. And so that's when you increment, the first version. So that's going from version 1 dot something to version 2 dot something. And what this does is it provides an ordering and a precedence to the various versions of your components. You probably want to, you're not going to really experience it here in this course, but as you work on bigger and bigger projects that have lots of different either third-party or first-party libraries, components that all go into building it, you need to know about this stuff, right? You need to understand what version of the library you're using. If you're using a library, an open source library, and they publish a new version because it's got some security fixes in it, right? You need, you're going to need to take that in, and by looking at the version, if they're following semantic versioning, you'll be able to understand sort of like what you're getting. Maybe it's a little change, maybe it's a big change. Oh, they had to remove some API that was completely insecure. Oh darn, you might rely on that API, and now you'll have to adjust your code accordingly. Anyway, so and I talk about like how to branch and stuff. But when it comes, and so then that whole, so again, when I work on like the artifact that contains the abstract phone call class, which is the projects.jar, and I need to increment the version for some reason, like for instance. Last time I taught, I used the zone date time, which used time zones, which was kind of lame. It sucked. I didn't like it, so I wanted to use local date time instead. I changed the API, and therefore I went from like version 1.1 to 1.2 or something like that. I'm like, oh, I can use semantic versioning in my own stuff. Now you don't really see that because you're just depending on version 1.2 right now, but sort of like for me as the developer of that, I got to think about these things. And when I did that, I made a branch in the source code to develop on. That was that snapshot branch. So snapshotting actually is a concept in Maven that allows you to get a version under development, always give me the latest build of it until you're ready to release it. And then once you release it, then you depend on the released version instead of the snapshot. But anyway, good stuff about this. So anyway, that was a little detour through semantic versioning. Any questions? Have anybody encountered semantic versioning before? I don't know if you're going to use it anytime soon. Probably not as a student, but it's something that if you use third-party libraries and you want to understand their versioning schemes, they're very likely using semantic versioning. Oh, and you can find out more about it at semver.org. This is a nice little white paper that they put together that explains all of the stuff. Oh, and of course, it's got a BNF grammar, so it must be good computer science. Okay. One other thing real quick. I wanted to take a minute to, actually no, it'll take more than a minute. But you know what, I guess here's I'll start in on it, but I do want to make sure that we have enough time for the kata. So I ran Maven Site to generate a site for my phone bill project. And I just wanted to walk through what you get here. Let's see here. Yeah, so here's the index.html. So I ran Maven Site and it generated these HTML pages for the project. And all of this stuff is derived from the code in the project itself. So if you go look at things like the pom.xml for, let's see here, this is for, no, that's Kata's again. Oh, sorry, do I not have the, I don't even know what the hell this is. No, this is the right one. So if we go look at the top level pom.xml in my Joy of Coding Summer 2024, you look at the top one right here. I'm just going to make this wider. It's got all sorts of stuff in it. So here's, because the pom.xml, and pom is the project object model, pom. This describes the Maven project. So it's like, hey, what version of the model are you using? What's the parent? So POMs can have a parent POM from which they inherit a lot of configuration. And then, I should go back and change things like my user ID. This talks about the version of the artifact and stuff like that. But then it's got things like a description and a name and all of things and like a URL for it. And all of this is contained here, is used to generate this information in the index. Again, this about phone bill project, the phone bill project, all this, like the description here, comes from, I'm looking at the top level one. I want to look at the one in the phone bill project. Yeah, there we go. The name is phone bill project, which then is put right here, and here is the description. And you can put all sorts of things like who are the developers, and then that's used in the, let's see, project information team. Yeah, great. And so then, like this team page is generated from the developer information. Okay, great, you can take things. And then like the dependencies are also, let's see here, can't remember where they're. Dependency information, right? Well, both dependencies and dependency information. So here's a report all about the third-party code that you rely on. And you can find out that, oh, look, I'm using, this version of JUnit. I'm using this version of Hamcrest. If you're developing an open source project, these are the kind of information that you'd want your consumers, you'd want the people that use your code to know about. And Maven makes it super easy to generate all this information. As a matter of fact, and they've got this whole series of plugins that will generate these reports for you. And and they're always updating things. You can put like custom skins on and everything like that. It's really great stuff. Additionally, I've configured the Maven projects to run a whole bunch of reports. We saw the Jacoco test coverage report, but you can also get API documentation from it, right? And all of this is, is generated from your code. So here's, a Java comment that gets turned into HTML documentation. Oops, did that open a? Go back. Generate reports. And there are other things like, you can get the results of all of your unit tests, right? So it ran 8 unit tests. There weren't any errors. This is really great. You can then, drill down by class and stuff like that. You can also then get source code analysis, like spot bugs. This is really cool. So what spot bugs does is that there's this huge database of, they're more than code smells. They're like coding patterns that are known to cause problems. And so it'll run all these analyses on your source code and it generates these reports. It's telling me I've got one bug in there, and it's saying, okay, here on line 16 of project1.java, I've got a dead local store. Well, let's go look at the code and see what it tells me. Line 16 is, oh yeah, right. It creates a new object, it puts it in this variable, and then the call variable is never used. This could be a problem, right? Maybe it's like, you're just kind of wasting your time, or hey, this is something you should look at because you're creating an object, you're assigning to a variable, and then never using that variable. Now, IntelliJ is probably complaining about this too, but what this does is it runs a report for basically anybody to see in order to open up IntelliJ in order to do that. So, these are the kinds of things that a robust build system like Maven can give you. So yes, it can compile your code, but because there's this whole ecosystem around it, you can very easily get code analysis, generate these reports, build a whole site. As a matter of fact, if you go and look in the README, I have some instructions that actually will tell you how to generate a site and publish it up to a special place on GitHub so that it's visible to the world. You can generate all this stuff for your project, and because all this code is open source, you end up seeing lots and lots of projects out there, lots and lots of things like JUnit, all these all this third-party software that people use that leverage these reports, so you have like a very consistent and common environment for learning about all these projects. So. I wanted to spend some time in class today sort of telling you about these more advanced or professional topics in software development. Things like continuous integration, things like semantic versioning, and now some of the powerful reports that you can build with a Maven site with Maven. Okay. Any questions on that stuff? Okay, I think it's time for a break. So let's take 12 minutes. Come back at 7:15, and then we will begin the pair programming. On the recording, so that you can turn into a TikTok and make fun of me or something like that. Sorry, I don't know. So yeah, a question came up during break, which is, hey, when you're writing unit tests, should you only test through a public API, the public APIs, the public methods for the classes? What about private or anything like that? Well, so in Java, you can't call a private method from outside the class. So you can't test private methods. That's okay. Sometimes you need to. One of the things that I've done is I've elevated the visibility of a particular method so that I can test it, and that's when I use that at visible for testing annotation. So sometimes I'll do that. But I think there is a very valid school of thought that says, hey, you should, in terms of APIs or just in terms of visibility, your unit test should favor public APIs. And yeah, I think that can be very fit to purpose, especially if what your product is or your component is an API, right? So that is how the user is using it. And it's probably fair to say that most of the unit tests that I write are like that. because I take a test-driven approach, I tend to think of like, well, what is it that I want to accomplish, right? Sort of at the high level. Okay, right, I'll write a test for that, and then I start implementing it. Sometimes I'll refactor. It's like, oh wow, all this code really should go into its own class, and then I have to move some tests, that sort of that focus on that functionality into another test class to make sure that things line up, things are easy to understand. So I think it's a good way to start. And but then be open to like, oh, maybe it's not always fit to purpose, or maybe if I do feel that I have a private method that I really want to test, maybe that is, if there's enough functionality there, maybe that's an indication that that logic ought to be moved into a different class just so that it can be, moved into its own class just so that it can be tested better. And that's fine too, right? As your code evolves, what refactoring can give you then is more logical groupings of the methods. That's what classes are, right? You can find that that you'll refactor that way. Yeah. Okay, thanks. Okay. Oops, did I stop sharing? I think I did. Awesome. Yay. Yeah, right. Happy New Year indeed. Cool. Okay, so let's do some pair programming. So last week we did our first pair programming Kata. It was a simple leap years one. Tonight will be a little bit more involved, but I want you to remind remind us of sort of how this works and what we're doing. There are two people having two brains on a problem, and I encourage everybody to get experience again with both roles, both the driver and the navigator. The driver is the person whose hands are on the keyboard. They're sort of like the words. They're the person who is typing things in. And the navigator is the person who is coaching or guiding the driver, thinking about sort of the big picture and saying, hey, where do we want to go next? And that's sort of the brain, if you will. And the idea here is that in order for something to go from the navigator's brain into the computer, it has to go through the ears and the hands of the driver. And as I hope you got to experience last week, this is an interesting dynamic that allows good work to be done, and done in such a way that if you switch off pairs pretty frequently, one person doesn't get tired or burnt out or feels that they can only contribute in one way. So we'll follow the same structure tonight, in that we'll do a series of Pomodoros. I heard last week that people want a little bit more time, so do you want to increase the length of the Pomodoro? So maybe make it more like, well, I think I heard like 10 minutes of, yeah, so actually, wait, what did we do last time? Yeah, so instead of 7 minutes of coding, we'll do 10 minutes of coding and then 2 minutes of reflection, so it'll be 12-minute Pomodoros, or 13 actually, because there's the switching that happens there. So yeah, we'll do that tonight. And but first, one of the things I recommend is that we'll start off with 10 minutes just for talking about the problem. One of the pieces of feedback that I got when I taught in the winter was that the first time we did pairing, the first time we did mobbing, they just started right into it. And it was kind of hard for people to get started, hard to wrap themselves around the problem. So let's just, and they said, and then the next time they did it, they said, hey, how about we just start with like 10 minutes of talking? And so, so that we'll do that. We will, yeah. So, so we'll start off with just one 10-minute round where we'll study the problem. And the problem for tonight, our kata, is called diamond. Sorry, where is it? There it is. So this comes from our good friend Alistair Coburn. It's a really simple, luckily it's an easy problem description. So unlike that leap year that I went on for too long, this one's pretty straightforward. So you are formatting text, and the whole idea is that you're given a letter as a capital letter, and what you do is you create a diamond whose top point and bottom point. Sorry, whose top point and bottom point are letter A, and then whose left and right points are the letter that was input. And in between those points, you have all the letters between A and the input letter. And so you end up with something like this, right? Here's the diamond for A, and so you've got each line has ABC and then CBA, and so you have something that is is symmetrical. symmetric around the middle, which is the letter that was input. And so then this is the Kata. Any questions about sort of like what this is or what to expect? Yeah, it's pretty straightforward. Oh, there's a question in the chat. Oh, does inputting A print one A or two A's? I don't know. You can decide for yourself. You're kind of graded on what it is. So yeah, that's a good question. I think I would just have one A. Is that right? Maybe. Yeah, I don't know. Decide for yourself. You and your pairing partner can determine that. If you update your checkout of the Kata's Summer 2024 repository, you'll see that there is a whole bunch of a new set of partners. Sorry, there's a new set of projects. Lots of keywords tonight. And there are 15 of them. And I think what I'm going to do, yeah. So there are 19 people. Well, there's actually 18 people who are remote because I'm one of the participants here. So let's reserve I'm going to create some breakout rooms, and those breakout rooms will be breakout rooms 1 through 9. If we have just exactly the right number of people, we have 1 through 9, and then the people who are here in the room will be 10 through, I guess, 14, and so we can figure out here who that is. Yeah. So after you update your repository, you might need to refresh your Maven projects because there'll be new projects that are added. And so if you go over, for me, it's on the right. There's this Maven section, and you can open up over here on the right, and then you can say reload all Maven projects. And what that should do is go through and scan all of your projects again, so that and it'll create real Maven stuff for them. And then you can just go into your pair and find the diamond class, and then there is all empty, right? There's a diamond test. And again, I encourage you to do test-driven development, either through unit tests or through integration tests, taking something from the command line. But I don't know, it's probably easier just to use an integration test for this. Okay. It looks like people are partnering up in the chat. That's cool. Oh, how did I open the Maven? For me, it's over on the very right. There is a right tab here over on the gutter. I don't. Maybe the newer layout works a little differently. I can't remember off the top of my head. I bet something you and your partner can figure out pretty quickly, though. Awesome. So, any questions before we dive into it? Nope. So, okay, I am going to then open up the breakout rooms. I'm going to create. Does it have to be a different partner? I'm not going to check on that. Really, it's up to you. Hey, you know, I see 9 breakout rooms. Yeah. You can be with someone that you've been with before, get some more experience with them, or you can try someone new, or maybe you'll just get assigned. Oh wait, did I? Oh, sorry. Wait a second. Recreate, and I don't want to assign automatically. I will let participants choose the rooms. There we go. Okay, I have 9 rooms. I'm pretty sure I have 19 people. Yep, that should work just fine. Open all rooms. Okay, have at it, folks. Go choose yourself a room. And then I'll put 10 minutes on the board for us to get started. Okay, let's assign here. I'm going to pause the recording. I don't think we need anything else here. Okay. Hey everybody. So we only got a couple minutes left before we're done, but I want to hear about your experiences tonight. So this is your second opportunity to pair program. It was a different Kata, and some of you were remote instead of being here in the classroom. What did you find? What are some of the observations that you have, and what was the same? What was different? What are you so curious about? Oh, you like the length. So you like having a 10-minute coding. Yeah, okay, good. So was 10 minutes still good? Did you want more? Was it so not too much? Yeah, 10 minutes was good? Yeah. Okay, felt longer, and so is it fair to say that you got you had the right amount of engagement, and you may get a little deeper with 10 minutes? Okay, good. Let's see. Yeah, lots of other people like 10 also. Okay, awesome. Other feedback here in the room?
Well, I kind of missed the memo. I thought it was
Yeah, I think you ended two rounds of planning. Oops.
okay.
Yep.
I don't know, that's kind of a little rush, but then we really had our
Okay. Yeah, but you felt solid going into it. Yeah. So yeah, we could use a little bit more time. Okay. Yeah. Pair in the back, did you finish? I saw like the hooray, or is like I'm so glad we're done. Finished and got it working. Nice going. Cool, cool, cool. Nice. Okay, so let's see here. Good opportunity for do some remote calculation. Okay, good. Enjoy the opportunity. Okay. Someone said that remote was much harder, especially when the computer is slow and someone's using it. Or oh yeah, both Zoom and IntelliJ can put some stress on things. Yeah, like 10 minutes. Actually, yeah. Other observations about what it was like being remote. And feel free to come off mute. Andrew, I see that you're unmuted. Did you want to say something?
Uh, that was an accident, but yeah, I mean, I think like I was in a group of 3 actually. So I think that made it a little more difficult. Like it's just not knowing when someone else is thinking about talking when the other person is talking is like,
Yeah.
it's either, I mean, we probably could have had our cameras on, but I don't know. That's all. It just seems to be the common issue with Zoom.
Okay, didn't have cameras on. Well, that's interesting. Yeah, right. It's better for worse. It's like, yeah, when you're not sitting, we can't see someone else's face. It's hard to know, how to engage. Nice. A couple more messages came in. Right, can't point to their screen with your finger. Say the number. Yeah.
Doesn't Zoom have a marker feature? I know Slack does. Like you can put on someone's
Yeah.
screen.
I don't know if our Zoom might have that disabled, or maybe it's something I need to disable, or it's something I need to enable. Worried about like graffiti or whatever it is these kids these days. Nice. Okay. And then a couple other people are saying that being remote is harder because you have to you have to explain everything and you can't look someone in the eye. Yeah. Okay, right, yeah, right. Someone's pointing at something and you can't see them pointing at the screen even if they have their camera on, so it's hard to know. Okay, well, good learning, right? Good. Awesome. But still, overall, enjoyed it. Great. Okay. Hey, before we break, I just want to give a preview of next time. So we are done with session 8. So next time is session 9. Okay, so we're heading into the second half of the course, which means that the topics get a little bit more challenging, and we'll start seeing that on Monday, where we talk about the web applications and REST. We are going to create our project 4. Class is going to be a new Maven project, so instead of just a single command line application, this will be a REST application where there's going to be a web server, a web container, that then serves up a REST API to a command line client. You'll be creating a new project, a new Maven project. It'll be different, and so we're going to spend the entire class making sure that everybody can get started with it, even if you don't, start working on the project, because you still have projects 2 and 3 in progress. I want to make sure everybody can get off the ground with it. And we'll explore the project, the various pieces, parts, because now you have 2 Java programs talking to each other, and that's sort of a whole dimension of added stuff to learn about. And then next Wednesday, we're going to continue that by doing a bunch of code refactoring to take the REST API project from sort of what it is out of the box to something that looks a little bit more like your phone bill. So even though you don't have to come to class, these are pretty important lectures because these are pretty important class times because project 4 is an order of magnitude more complex because it's a distributed program instead of just one. So please be sure to attend and be attentive during the class. Awesome. And with that, that's everything we got for tonight. Have a great weekend, everybody. Reach out to me on Slack if there's something that I can do for you, and we'll try to get the Project 1 feedback to you as soon as is practical. Bye, everybody. Bye now.
Bye.
Bye.
Bye, have a good night.